Hello. In this video, we will go over section 6.2, which is on the normal distribution. The normal distribution is a continuous probability distribution. That means that the distribution is presented using a graph, and probabilities are calculated by finding the area under the curve. The normal distribution is popular because it fits many different real-life distributions. This encourages its use in modeling hypothetical distributions for simulations and predictions. Some examples of distributions that fit a normal curve are physical, such as height or newborn weight, or mental, such as aptitude tests or IQ. There are many, many more. The characteristics of a normal distribution are it's unimodal and symmetric. The majority of the distribution is near the center, and small amounts of the distribution are in the tails at either end. If this sounds familiar, it's because the normal distribution follows the empirical rule. Here are some examples of normal distributions that exist in real life. So cholesterol, you can see the pattern for cholesterol here, the distribution for cholesterol. You can draw this curve on top of it. You can see the pattern for diastolic blood pressure. I can't read it because it's too small on my page. And you can see that curve shape that's fit over it. And then you can also see heights. And you can see the data for heights, and you can see this curve fit over it. And notice these curves all have similar shape. That's called the normal curve. Okay, and that's the core part of a normal distribution. And it's just that many distributions exist in real life that fit that shape, where you've got a lot of data toward the center that peters off, and then you've got small amounts of data in the tails. The normal distribution is defined using two quantities, the center and the spread. The center is the mean of the distribution and is described using the Greek letter mu. The spread is the standard deviation of the distribution and is described using the Greek letter sigma. The shape of the distribution is based upon the mean and the standard deviation. The mean is always in the exact center of the distribution. The standard deviation determines whether the curve is wide and low, that has a large standard deviation, or narrow and tall, that corresponds to a small standard deviation. So you can see over here in the image, if you've got a large standard deviation, then you get something that's shorter and wider. If you have a small standard deviation, then you get narrower and taller in terms of your normal curve shape. Normal distributions are defined using the notation n and then mu and then sigma, okay, and then just goes over those things again. And so, for example, if men's heights have a mean of 69 and a standard deviation of 3, and so we represent the normal curve as n parentheses 69 comma 3. And then women's heights have a mean of 64 and a standard deviation of 3, and so we represent those the normal curve for those using n parentheses 64 comma 3. Since a normal distribution is a continuous probability distribution, we can find probabilities by finding the area under the curve for a given range of outcomes. So suppose we wanted to find the probability that a randomly selected woman is taller than 62 inches. Right, so in that case, we would use the curve n of 64 comma 3, which we covered on the previous page. And then what we'd want to find is we'd want to find the area that's under the curve to the right of 62 on that image, right? So if 64 is the mean, 62 is going to be to the left of that. And so we're going to have this, the area of the curve is going to, go from that 62 value all the way to the right. If we wanted to go through and find the probability that a randomly selected woman was between 62 and 67 inches, then we would take the same curve. So again, that's n of 64 comma 3, and we would go through and put 62 on there, which is to the left of 64, and 67, which is to the right, and we would shade under the curve from 62 to 67. The area that corresponds to that amount is going to be the probability that a randomly selected woman would be between 62 and 67 inches in height. And then finally, we could go through and do the last case, which would be less than. So again, if you put 62 on there, then the area under the curve is going to be to the left of 62, and that is going to correspond to a probability that a woman is shorter than 62 inches. Let's look at another example here. So according to McDonald's fact sheet, Each serving of ice cream in a cone is supposed to weigh 3.18 ounces. In reality, it's not possible to consistently serve exactly 3.18 ounces. So suppose that the amount of ice cream dispensed follows a normal distribution where the mean is 3.18 ounces. What is the probability that a customer will get less than 3.18 ounces when they order an ice cream cone? And then next, what if McDonald's modified the machine so that the amount dispensed had a mean of 3.7 ounces? Would that increase or decrease the probability that a customer would receive less than 3.18 ounces? All right, let's look at the solution to that. All right, so the probability of getting less than the mean is always exactly 50%. So, right, the mean is at the exact center. So if you're asked what's the probability that you get less than the mean, it's always exactly 50%. So if the mean is at 3.18 and you're asked what's the probability of getting less than 3.18, then you'd shade to the left of 3.18, and that's always going to be exactly half of the area under the curve. The area under the curve total is 1 or 100%, and so half of that's 50%. If we went through and put the mean at 3.7, now we're still using 3.18 because that's what's in the fact sheet. That's the amount of ice cream that someone's supposed to get. If we go through and move the mean to 3.7, then the effect that has is it makes the region that's shaded, it makes that smaller. And so that's going to be is the probability is going to be smaller that you get something less than 3.18 if the mean is 3.7. And that does kind of correspond to what you'd think logically, right? If you want to know what's the probability that you kind of get cheated, you get less than you're supposed to get when you order ice cream at McDonald's. If they have the machine set to give you 3.18 ounces, and that sometimes you get cheated and you get less, and sometimes you get more, and then they go through and they change the machine to 3.7, then the chances of you getting less than 3.18 are going to go down. So if they give you more, if the machine's set to give you more ice cream, then the probability that you get cheated and get less than you're supposed to is going to go down. That makes sense, right? All right, so next, percentiles. The X percentile is the measurement that separates the bottom X% of a distribution from the upper 100 minus X%. So for example, if 2 separates the bottom 10% of a distribution from the top 90% of the distribution, then we call 2 the 10th percentile. All right, and going back to the mean, since the mean is always separates the bottom 50% of a distribution from the upper 50%, the mean of a distribution is always the 50th percentile. Let's look at some examples here. So suppose we're using standard units where the mean is 0 and the standard deviation is 1. And then suppose that negative 1.28 is the 10th percentile and 1.28 is the 90th percentile, then you end up getting the following results here below. So if negative 1.28 is the 10th percentile, then negative 1.28 is going to be the score that separates the bottom 10%, that's going to be 0.1 in the area under the curve, from the top 90%, right? 10th percentile, 10%, area under the curve, the total is 1. And so 0.1 is going to be 10% of 1. Hopefully that adds up. Okay, and so the 10th percentile is going to be the area under the curve that separates the bottom 10% from the top 90%. And then the mean here, if you're using standard units, that's always going to be at 0. And that's going to separate the bottom 50% from the top 50%. Okay, and so that's the 50th percentile. And then we have positive 1.28. If that's the 90th percentile, that separates the bottom 90% from the top 10%. And so again, if that is going to correspond to 0.9, if the total area under the curve is 1, then 0.9 is 90% of 1. And so that's the 90th percentile. Okay, and so that's it. So we've got probabilities and percentiles. So if you're looking for how to actually calculate these things, that's going to be in a separate video that's going to be titled, I believe, using StatCrunch to calculate normal probabilities and percentiles. So if you're looking for actual examples of how to go through and calculate these, we're going to use StatCrunch to do that. And that's in a separate video. So you want to go through and watch that video next. Okay, but this video does got to go over what these things are, what the normal probability is, and what a percentile is. Thank you for watching, and I'll see you next time. Bye-bye.